and welcome everyone, and thank you for joining. As Bill mentioned, what I'm going to do is do a short presentation, give you a little bit of an overview of how QuerySurge helps with continuous testing in the DevOps space. If you have any questions, either during the presentation or during the product demonstration, please put them in the chat window. After the demonstration is over, we'll have a Q&A session where we'll go through all the questions and try to get them answered. If for some reason we have too many questions and we don't have time to get them all answered, we will follow up with those questions via email. With that said, let's get started. Before we start, though, I want to talk a little bit about our company, RTTS, for those of you who are not aware. We were founded in '96. Our headquarters are in New York, where we're delivering the call from today. We started out as a service organization focused on software quality, specifically automation. Those engagements led us to do some data testing, and that was kind of the genesis for where QuerySurge came from. QuerySurge launched in 2012, and since we launched, we have over 120 customers in 17 different countries and a wide partner network, which helps us enable our customers in getting the implementation done successfully. So let's talk a little bit about the DevOps challenge that people are running into. So the goal of any successful DevOps implementation is to automate as many of the tasks around development and operations as possible. So as you go through the different phases, from planning to coding to build to test, all these different components, we want to be able to automate the transition from one phase to the other. And a good DevOps solution will be able to take any changes that get planned in the early phases and have those changes propagate down through all the other phases of the DevOps procedure. Of course, the challenge is some of those changes are difficult to implement. Traditionally, testing has always been a challenge as developers code changes into the application or into the, in our case, the data architecture. How do those changes make it into the test? How do those tests get updated? And how do they get executed to validate those changes? So that's one of the challenges we're looking to solve. So it's important to note how data testing is currently being done today so we can see how we can address those problems. So one of the more common ways that data testing is done through sampling. Sampling is a manual process where a tester will run a query against the source system, run an analogous query against the target system, retrieve result sets from both, and analyze the data visually to try to determine if there are any data anomalies. Obviously, this isn't a very efficient way of doing this. You'll only be able to test a small fragment of your overall data. It's very time-consuming and labor-intensive, and it's prone to errors. Another data validation method is minus queries. Minus queries is when you query a source system and a target system and essentially subtract the result sets from each other. In an ideal scenario, a minus query will return 0 records, indicating that the source and the target information is the same. If there are any records that do come back, those are typically records that are either in the source system that aren't in the target system, or target records that aren't in the source, or at least do not have an analogous match. So a lot of issues with minus queries, such as putting stress on the systems being tested. You have to run the query in both directions in order to completely validate the data, and the data architectures have to be linked in order for this to work successfully. What other organizations may do is create some homegrown solutions. So they'll build a utility that enables them to perform the testing the way they need to. But this is usually difficult to maintain and upkeep, and if institutional knowledge leaves, it becomes difficult to continue to use. So what is the ideal solution for testing data in your DevOps strategy? The solution should be able to validate large amounts of data quickly, should be able to validate difficult transformation rules between various source and target systems that are being tested, should be able to be integrated into the DevOps pipeline to achieve continuous testing, should be able to detect requirement and code changes and have tests either reflect those changes or alert team members when those changes occur. It should be able to inform team members anytime there's any type of failure in real time. And it should be able to store historical results and provide analytics around past executions. And that's where QuerySurge comes in. We position QuerySurge as the smart testing solution for automated validation and testing of data. Our use cases are listed below. We started out primarily around data warehouse and ETL testing. We also support big data environments such as Hadoop clusters and data lakes. We're going to focus on DevOps and continuous testing in this webinar, where we can show you how this can integrate seamlessly into any type of DevOps pipeline. QuerySurge can be used for data migration projects, whether you're moving data from an on-premise solution into the cloud, or you're changing your data architecture and you need to switch from one vendor to another, or if you're just doing an upgrade of the vendor's latest software. QuerySurge has an interesting solution around BI report testing. We capture the data underlying the visualizations in BI reports, and we can take that data and compare it either to a back-end data warehouse or data mart, or to other reports that you may have similar data in. And then enterprise app ERP testing. If you have multiple data feeds that are being pushed through an ERP system, QuerySurge can validate that those data feeds are getting into the system accurately. So we know that C-level executives are using BI and analytic reports to make critical business decisions. The assumption is that the underlying data behind these reports is accurate, and through our experience, we know that's not always the case. Bad data can get introduced into the architecture, which impacts the validity of these reports. So as data moves from its initial source through the data warehouse to the data mart, your architecture may have data lakes involved, migration projects going on, enterprise apps and ERP systems, moving the data through the architecture until it eventually gets to the report. At any one of these moves, there's the possibility of bad data being introduced into the system. And that's the problem that QuerySurge helps solve. Some of the benefits of our solution: we have a query wizard, which is used to build tests for data migration projects or for tests that require no transformation between a source and a target. It provides a graphical user interface, which drag and drop functionality, which allows you to build these tests very quickly without having to write any type of code. For more sophisticated tests, we have a design library that has a lot of really nice features, such as thresholding, reusable snippets, a staging area, and a variety of other features. Everything designed in QuerySurge is designed with automation in mind, which allows you to execute these tests quickly. We support a wide variety of different platforms, whether it's data warehouses, data marts, data lakes, mainframes, web services, BI reports. We use JDBC technology, which allows us to connect to all these different potential source and targets. DevOps and continuous testing is what we're going to illustrate today to show you some of the use cases of how QuerySurge can be implemented seamlessly into your DevOps procedures. And we provide a wide variety of data analytics and data intelligence reports to give you information about your test results and about your data. We also provide backend access, which will allow you to put any type of BI tool against the metrics that we're gathering, or just to query our database to retrieve information to build any type of custom report that you may want. QuerySurge installs on its own server, has its own application and backend database. Users will access it through the browser. And QuerySurge has a concept of agents. The agents will actually make the request to the various data stores, bring the data back and to the server for analysis. By spinning up more agents, it allows you to run more tests in parallel, which cuts down your overall testing time. Users access the application through all your major browsers, which are supported. OSs are Windows and Red Hat Linux, and it can install either on a physical machine, on a virtualized environment, or in the cloud. So it can be installed in Azure or AWS or all the other major cloud vendors. And as I mentioned, the technology we use to connect to the data stores is JDBC. So what that means is as long as there's a JDBC driver, QuerySurge is able to access the information within that data store. You see a partial list of some of the different technologies that we support. QuerySurge comes bundled with about 15 different drivers. Those are either drivers we've developed ourselves or that vendors allow us to bundle with our software. For any of the ones that don't come bundled, you can just go to the vendor's website, download the JDBC driver, put it on one of our agents, and that will allow you to configure the connection and utilize it for your testing. So in a nutshell, how QuerySurge works is we have a concept of a test which is called a query pair. And what a query pair does is it runs two queries, one against the source system and another against the target system. So your sources may be a traditional database, a mainframe, flat file, or web service, and your target may be a data lake, a data warehouse, or a BI report. Each test, you can arbitrarily choose what's a source and what's a target. When the test executes, it will query both systems, bring back the result sets from both source and target, and compare the data and look for any type of data anomaly, such as a record that didn't make it into the target system, or some type of transformation issue, or any other type of data anomaly or bad data. And then our analytics will be able to show you exactly what failed, what passed, provide email notifications, and high-level summary reports of those executions. So typically, if you look at a simplified data architecture, you'll see multiple sources being fed over into some type of data lake, eventually going to a data warehouse, then a data mart to your BI reports. When the data moves, ETL developers are using requirements or some type of mapping documentation which governs how the data moves and what type of transformation needs to be applied to it during the move. So from a testing perspective, QuerySurge testers will build the same types of tests using that same requirement information to validate that the data moved correctly. And we can run those tests against the different endpoints to find exactly where the bad data was introduced into the architecture. And what we're really pleased to announce is our new version, which just released, which is our QuerySurge for DevOps. It will allow testers to dramatically increase the automation that they're doing and pretty much utilize QuerySurge any way they feel would be beneficial to their DevOps process. It's the first full DevOps for data solution designed to improve their data quality at speed. Has over 60 API calls with over 100 different properties to perform all types of operations within QuerySurge, and it allows it to be integrated into any of the different DevOps components that you may need to be successful with your automated testing. So with this new DevOps API, customers now have the ability to perform and design analysis operations externally from QuerySurge, which allows QuerySurge to be adopted and integrated into any other DevOps process that focuses around data. So whether that's creating, modifying, or removing existing items within the QuerySurge application, whether it's getting a better control over execution, or whether that's retrieving specific results or specific data that was captured during test runs. Previously, all these commands, or at least the majority of the commands, would only be able to be performed through the QuerySurge user interface. But now we're giving our customers the ability to execute all of these commands externally, which allows QuerySurge to be integrated into any type of framework that they may have. So if you take a quick look at the DevOps marketplace and the different products that are being used, so if you're using build tools like Jenkins or Bamboo or Azure DevOps, QuerySurge fits in with the other testing products and will be able to be executed very similar fashion to tools like Selenium and JMeter and some of the other tools that are currently used in this type of framework. So the standard or base version of QuerySurge does have some basic API calls, but you'll see it only accounts for 15% of the total API calls that are now introduced in our DevOps release. We now have over 9 times the amount of API calls from our base solution. And just to kind of illustrate that, our base API had commands for execution and just basic execution where it would run a group of tests and return whether there was any failures that occurred. We did have additional APIs for dealing with some of the test management solutions that we work with, such as Micro Focus's ALM or Azure DevOps or IBM Rational Quality Manager. But the new DevOps API, you'll see, has a much more extensive list and pretty much can be performed against any of, again, the different commands that you would typically do through the user interface can now be done through our API. So what I'd like to do now is take a look at a few of use cases where this can be implemented. So the first would be to have tests automatically initiated after ETL execution completes and have conditional logic applied based on specific results of those executions. So for example, if you have a DevOps pipeline, you may have a job that gets executed. So let's assume it's some type of ETL job. Once that job is complete, you can have QuerySurge tests automatically kicked off and triggered. Through the API, it will make the request to the QuerySurge server. The QuerySurge agents will run the tests and bring the results back to your pipeline. And not only can we get whether there's any passes or failures, you can do a deep dive analysis of the data that's being returned. And you may have a rule built into the pipeline that says, well, if 98% of my data is accurate, then I'll consider that a passing scenario and I'll move forward. But if a higher percentage of the data is inaccurate, then you can have a rollback job, stop the process, kick off automatic emails so people know that there is an issue and can go and investigate it. The second example is when new environments are deployed, you can automatically create new connections in QuerySurge, take tests that were running against an old environment, and run them against a new environment. So let's say, for example, you currently have a QA environment, and you have a folder that's dedicated to running tests against this specific target. And all those tests have a connection that are specified to hit this target system. Well, when a new environment is rolled out, let's in this case call it pre-pod, we can automate the process of testing this new environment. We can automatically create the new connections. We can duplicate the tests that exist in the QA test folder, copy them into a new folder, in this case called pre-production tests, and then modify those tests to use the newly created connection to the new data store. And this can be all automated with our DevOps version of QuerySurge. So you can take out the manual process of having to copy those tests over, modify them all, create the connection. This can all be done in an automated fashion and executed on demand as soon as the new environment is deployed. And the third use case we're going to take a look at is to have QuerySurge tests automatically analyze and detect changes to the data store schemas and have those changes reflected in the tests. So for example, you may have a test that's combining information from multiple sources and taking that information and validating that that information is making it over into a table in our target data warehouse. So these tests would be constructed manually and be set up to execute in QuerySurge. But what happens when there's a modification made to the target system? So let's say that the business users decided that a new field needed to be added to the data warehouse table. So unless the testing team is notified, that new field is not going to be tested. And in the past, even if they were notified, somebody would have to go in and manually modify the test to now take into account this new field. But with the new QuerySurge DevOps API, it gives you the ability to analyze the schema changes and then using machine learning or pattern recognition to try to make a determination as what field from your source should map to that target field. And once that determination is made, to automatically modify the test to reflect that detection. So for example, if we're taking a look at an existing query pair, so you can see here we have a source query on the left, joining multiple tables, and then taking that data to compare it against the target system on the right. Once development makes that change, it adds the new table to the data warehouse. Again, using the QuerySurge DevOps API, we can analyze those schema changes, try to determine what field from the source should map to that target, and then automatically adjust the test to reflect that change. Now again, this would be implemented using pattern matching or machine learning. It may not always be 100% accurate, If it guesses correctly as far as the correct match, then the test will pass and everything's good. And even if it guesses incorrectly, if the test fails, that'll at least drive the tester to analyze the results and try to determine what the failure is and then make the necessary modifications. As opposed to the previous case where if no one notified the tester of the change, it may just be something that's not tested, and that could introduce bad data into your architecture. So I hope that gives you a brief overview of QuerySurge and the new DevOps features. What I'd like to do at this point is turn the control over to Matt Moss, and he's going to show a demonstration of some of these use cases.
Thank you, Eric. So I'm going to share my screen, and what I'm going to do in this demo is give you a nice overview of QuerySurge as well as our new DevOps features. So what I have here on my screen is a sample query pair. And the reason why I'm showing this is very important to understand how QuerySurge works before we dive into more detailed information such as our DevOps API. In its simplistic format, a query pair is a query that goes against a source system and a query that goes against a target system. We say system because QuerySurge can connect to pretty much any data technology out there, whether it's a traditional data store such as Oracle, MySQL, or SQL Server, a non-traditional data store like a flat file such as an Excel document, a CSV, or even a JSON document, a big data store such as Hadoop, or even BI reports. The query pair that you see here can be as simplistic or as complex as necessary to validate your data set. So any ETL logic or transformations that need to be implemented inside of here can be done in the language that's compliant with that data technology. If you're dealing with a simple migration, it could be as easy as a select star. And if you're dealing with something that's doing some aggregation, you might have to put some group bys or some aggregation into your query. Once you've created your query pair, all of the tests that you run inside of QuerySurge provide you very detailed results on the outcome of those executions. To see the outcome of any run, in this particular case, I'm going to show you a design time run. All I need to do is click on this design time run tab and click View Query Results right here. I'm going to focus on the Failures tab because that's really the most important item in this particular test, because we might be pulling in billions of rows, and we only want to focus on those rows that we've found some data issue or data anomaly. In this particular case, we're testing an ETL transformation, which is pulling data out of our source system and loading it into our data warehouse. And what we can see here is QuerySurge has scanned about 6,500 records and found 7 records that have some type of data failure. Whether this is a complete mismatch of our record set, this might be occurring if our ETL process is run out of order and our dimensional tables are maybe not up to date when our data is transferred over, or it could be caused by maybe an ETL bug itself where the logic is incorrect. What we'll also notice is we have a data truncation issue that's occurring in our customer first name, and this could be because we're dealing with 2 different data platforms, where maybe the table on our data warehouse is actually designed incorrectly, and so it cannot fit the data that we're trying to insert in. QuerySurge will be able to capture any of these particular failures and report them through the UI as well as directly through our new DevOps API. The information that you see here, we can manually export out as an Excel file, a CSV, or an XML. And if we're running this with our new APIs, we can actually programmatically pull all the records that you're seeing here, as well as get which column is showing a data failure. This way we can make intelligent business decisions in our code to either change the type of test that we're doing, roll back a particular ETL process that might have been pushed to production, or inform stakeholders that there's an issue in a particular metric. What I'd like to show you first is a very simplistic implementation of our DevOps API. And what I have here is our QuerySurge Run dashboard. This is a high-level view which shows you all of your previous executions that you've had inside of QuerySurge. QuerySurge will actually keep the results of all of your executions as long as you want to keep them. So if you have enough storage space, you can keep this results files indefinitely, which allow you to provide trending metrics to your team in terms of data failures. It also provides traceability if you're in a high compliance industry That way you can go back and say, we did test this last year, and this was the outcome that we had achieved. On the right-hand side here, I have Jenkins. For those that are not familiar, Jenkins is a job system. It allows you to really speed up your continuous delivery process by automatically scheduling and chaining multiple sets of jobs together, whether they be ETL jobs, building of code for, say, Java or C#, or pretty much anything out there. In my particular Jenkins instance, I have 2 jobs that are set up, and they're both pertaining to specific ETL states that I'm going to be testing. So if I click this first job, which is our sales job, what you'll notice here is Jenkins has a history of all of the previous runs that I've executed with this particular job. And this could be scheduled maybe automatically overnight to kick off at, say, midnight to not impact any reporting systems. Or it could be a job that is dependent upon other jobs that are executing throughout the day. As a tester, it would be a big challenge to constantly monitor these jobs and run your test validations after every one of them has completed, because you wouldn't know exactly when those jobs were going to be kicked off. Also, you won't know how long those jobs will be taking to execute. With QuerySurge's DevOps API, you can actually have QuerySurge automatically get kicked off by your CI/CD tool, such as Jenkins, without any interaction of the testing team. What I'm going to do right now is kick off a manual build. And this is something that could definitely occur in your current production environment where someone is just doing a new ETL process or overwriting some existing data, and they might be kicking this off without informing the team that this is happening right now. But because this job has now been linked to my QuerySurge instance, what's going to happen is the minute the ETL process is completed, it's actually automatically going to kick off QuerySurge and validate that data is 100% correct without any interaction of the testing team or any other team members. This ensures that all of the data as it moves from your different systems are going to be tested. What you'll see right now is our ETL process has just completed, and Jenkins is actually communicating directly with QuerySurge. It's initiating a new QuerySurge test, which we see right here, and it's actually going to monitor the test status every 5 seconds to see what is the test currently doing. At the end of the test, it's going to get the outcome of this particular run, whether it passed, failed, or errored out, meaning it maybe found a data failure in the data set, or maybe the host was not online. And it's going to return that result right back into Jenkins. And what we can see here, we have an outcome status that says that this particular run was successful. And we've actually flagged our Jenkins job to say that this was successful. If there was any data issues, whether that was the truncation issue that we saw in that previous example, an extra row in the source or the target, or something that you might have implemented, such as a business rule that failed, you can have that information flow back into Jenkins and make intelligent decisions in Jenkins to maybe roll back that job or maybe run a cleanup script, depending upon the data failure that occurred. Another example that I'm going to show you is a little bit more detailed. So in this particular example that I showed you before, we're just dealing with our execution APIs, which are run a test, get its status back in, maybe manipulate a few fields in that particular run. The example that I'm going to show you now is the one that Eric showed you just at the end of the slide deck. What I have here is a very basic query pair, which is going against a MySQL source system, and it's moving this data to a MySQL target system. In here, what you'll notice, on my source side, we are pulling in 5 columns. One of them is actually a transformed column, which is timesing our quantity by our price and rounding it to the second digit place. And it's joining approximately 3 different tables. On our target side, we are also pulling 5 columns, but we're doing a slight ETL transformation on our customer name, where we're concatenating our first name and our last name. And we're pulling all of this information from a single table. Now, I've experienced this personally when I was dealing with the testing environment, where changes are occurring constantly in production, and maybe some of those changes are not fully informed to all team members because maybe they don't feel like it is a big issue, or it might have just fell through the cracks. In this particular case, what I'm going to do is I'm actually going to manipulate the tables that exist on my target side and manipulate my ETL process to populate that particular change. And what I would like to have happen is I'd like to have QuerySurge detect this particular change and automatically update my query pair with what it thinks the change should be. What this will allow us to do is really test 100% of the data that is moving from our source to our target, but also speed up the testing effort by taking some of the workload off of the testing team. So what I have here is my MySQL instance, and you can see I have my table here, sales by day. And what I'm going to do is I'm just going to add a new column in here. And I'm going to call this column state. This column has absolutely no references in my query pair whatsoever, and I do not have an analogous column in my source system. The analogous column is actually called bill state. I'm going to click apply. And if we are testing like normal and we have our validation scripts, we would never notice this column. It might have completely incorrect information. It might not even be loaded. There might be no data in there. And this might be a non-issue, or if that data is now being pushed to a report or being used later down the stream, this could be really messing up all of the metrics that are being shown to stakeholders. So what we'd like to do is catch this change and inform team members or automatically update our query pair. What I have here is an ETL toolset. This is actually Pentaho. And what this ETL flow is doing is it's pulling those particular tables from our source system, so our sales data, our user data, and our item data. It's merging them all together, doing some calculations, and it's finally loading that data that we saw on our target system. If I click on this table output right here, and I go to database fields, you can see this is a new ETL flow, which is going to be populating my state fields from that bill state column that I showed you earlier. What I'd like to have happen is if I run this particular flow, I want it to automatically check that there was a schema change and try to update it. And you can see I've added QuerySurge directly into this ETL flow. And what it will do is it will actually notice that there is a change in the schema that wasn't previously detected. So if I kick off this flow completely outside, maybe as a tester, this is just the development team, or this is your DevOps groups that is kicking this off automatically with Jenkins or TeamCity or Azure DevOps, what you'll notice here in the output is this: once it hits the QuerySurge steps, it's actually extracting the metadata from the source and the target and trying to identify any columns that are no longer in a test that should be in a validation step. In this particular case, what we should see is it's going to identify that additional column that we've added and try to apply a new validation set for it. The first line that you see here is that it didn't identify any stale records. Stale record would be a record that is a column that is no longer used, or maybe a table that was deleted. We did successfully identify our new record, which is our state column. And then we went to our next part of our DevOps flow, which is to see if we can identify any rules or any mappings that need to be done for that particular column in order to validate that new information. What you'll see here is it's automatically attempting to map that new requirement in, and it was actually successful in that mapping. Once the mapping was successful, it's going to try to update the query pair directly in QuerySurge and then kick off that execution. If for some reason the DevOps logic was unable to figure out that particular mapping, maybe there was some complex logic that was in there, or it was what's called a derived table, what would happen is instead of trying to update this automatically, the code would actually send email alerts out to the team members saying, we have a new column, it's not being tested. Would you like to test it, or do we want to ignore this column for the time being? What I'm going to show you right now is if I jump right back into QuerySurge, you can see this is our old query pair. It has absolutely no update to refer to that bill state column. If I do a quick refresh here, what we'll notice is our query pair has been updated to now reflect that change. So on our source side, we now have a new column that's being pulled in for the validation purposes, which is our bill state column from our source side. And on our target side, we have now aliased that to our state column over here. The logic that you see in here is fully customizable. The sample that I wrote was actually written in Java. And as Eric mentioned, it used a little bit of pattern recognition and machine learning to check all of the previous mapping aliases to determine if state was ever aliased to another name, in this case, bill state. And we'll also try a few different ETL transformation logics to see if it can match up what column is necessary. So this is just one example of pretty much the infinite number of examples that you can do with QuerySurge's DevOps. As Eric mentioned, almost every functionality that you can do in our user interface, you can now do through our API, which really allows you to expand QuerySurge to create your own plugins and integrations, as well as to communicate with any tool set on the market right now. The API itself has a command line interface, which can be run both on Windows-based systems as well as Linux systems. And I'm just going to run the bat file right here. You can see that this is all of the commands that are currently available. If you needed more information on a particular command, say the get folder command, all you'd have to do is type help get folder, and all of the fields that are required for that particular item would be displayed here. In addition to the documentation directly in our command line that you see here, you can also go to our knowledge base, which has a huge amount of information regarding our API. All of the commands that we've written for our API are documented on our knowledge base. And if you wanted to look at a particular item, such as, say, kicking off a test run, all you'd have to do is go to our execution section right here, select the particular item you want to look at. So I'll say, let's look at execute scenario. And you'll see all of the parameters that are optional for this particular command. We have things such as keeping the results. If you wanted to, say, save space and not keep all of the results from those executions, you can do that. You can append the time automatically to the name of your scenario if you want to have a timestamp and unique names. And if I scroll down just a little bit here, what you'll notice is we provided sample calls for each one of these items. So that way you can get an understanding of what's going to be sent and what's going to come back to you. All of our responses for DevOps are parsed in JSON, so it's easily readable by pretty much any programming language out there, as well as most command line-based tools such as Windows PowerShell or a shell script. For those of you that maybe are interested in trying out the DevOps feature or just trying out QuerySurge in general, you can find QuerySurge's website by just going to QuerySurge.com. And in the top right-hand corner, we have this Try It for Free button. You click on that, you'll see we have a few different trial levels. Each one of them provides advanced features, with our proof of concept giving you almost every feature that's included in QuerySurge. If you wanted to try out QuerySurge, the base product, you can just go over here and click the Download the Trial button. And it only requires an email address. There's really no other piece of information required for that level. If you wanted something more advanced, maybe the DevOps feature or our BI tester module, you can download these trials over here. They do require a corporate email for those particular levels, but we don't use that email address to send out to third parties or the like. So if you're interested in those, we'd be glad to get you up to speed. Our final option is our proof of concept, and that's where we actually provide you a 30-day trial, and we can have weekly sessions, or you could submit support tickets for any questions you might have regarding QuerySurge. So I'm going to open the floor up to any questions that everyone may have. So if you haven't wrote any questions, or if you have any questions that you want to ask, feel free to enter that right now into chat or the Q&A window.
Great, thanks, Matt. So we're opening up the floor for your questions. We invite you to start typing them into the chat window if you have not already. All right, first one. What programming languages do you support for writing the API calls?
That's a great question. So when it comes to our API currently is a command line based API. It actually comes with a jar file. You can kick QuerySurge off with pretty much any programming language out there, as long as it has the ability to execute a process. So in the examples that I was showing, I was using Java, but we have examples using C#, PowerShell, shell scripts, and the like. So you should be able to kick it off with anything, any modern programming language right now.
Great. How many concurrent users can you make API calls at the same time?
So there's no current limit in terms of API calls. In fact, our API user does not take up a license per se. It does require credentials to log in, but it's not a licensed user, meaning you can actually log in to the UI and send API commands from the same user. We have no upper limit in terms of the number of requests that can be supported by our API. I would say, though, it is hardware limited. So if you're sending hundreds of requests per second, you're going to want a server that is capable of handling that much workload, especially because there could be a lot of validations that are being occurring if you're doing, say, an execution.
Can you run this from Microsoft Azure DevOps?
Yes. So you definitely can run this from Microsoft Azure DevOps, and we have a fantastic article. Let me see if I can search this right here. Let's see. We might have this as a slightly different naming convention. We have a fantastic article, and of course I'll have a little bit of issues trying to hunt this one down, regarding Microsoft Azure DevOps, because the naming has slightly switched over time. You can see that right here. So QuerySurge can directly integrate with Microsoft Azure DevOps. What you do is you create a unit test, which gets kicked off by your build pipeline or by any pipelines that you might be creating. We have had a lot of feedback from the team about getting us in, say, the Azure DevOps Marketplace, which is something we're actively looking to do to make it easier for you to add these already. But we have a nice step-by-step guide which shows you how you can set this up. And it's a really easy item if you're using Azure DevOps.
Next question. Will the API be added into any existing tool sets, such as becoming a Jenkins plugin?
Yes. So that's exactly what I was mentioning just now with the Azure DevOps side. We are looking to integrate directly into these tool sets. So that way you can have a plugin from Jenkins, a marketplace offering for the Azure DevOps side. And what these, I guess, integrations provide is a nice single unified interface to communicate with QuerySurge rather than having to write some code. Even though we have some samples for this, and I can show you that right here, we would like to make it even easier for you to integrate with all of the tool sets on the marketplace.
Since this is a command line based API, will it run on both Linux and Windows?
Yes. We have built everything based off of Java, and we provide samples that work both on Linux-based machines and Windows-based machines. So you should be able to kick this off on any server that you might have in production or in your testing environments.
What other products will this integrate with?
With our API being so open, as long as you can call externally from any of your tool sets out there, we should be able to integrate with any tool set on the market right now. We've named a few of them: Jenkins, Azure DevOps, but we can integrate with things such as Quality Center, or now ALM, Rational Performance Sensor, Functional Tester, and the whole monitoring suite from IBM. You can also integrate with TeamCity as well as Jenkins if you'd like. Pretty much anything out there we can integrate with, as long as it's also DevOps ready. So one of the main reasons why we integrated and created all of our APIs the way we did was to better integrate QuerySurge with all of the other tool sets that are in the DevOps space.
Will QuerySurge detect changes in JSON text files like it does for relational tables?
So the particular example that I was showing here regarding a table structure was a custom-based example where I actually wrote the validation for that. What it actually does is it creates a dynamic query pair on the fly to check metadata. You can write a similar functionality for JSON. The only downside is you'd have to parse the JSON file because JSON does not have, say, like a metadata table such as MySQL or SQL Server or Oracle has. So it'd be a little bit more work, but you should be able to achieve it.
All right, Matt, I'm going to read this. Hopefully you can understand it. How does QuerySurge help in the case of Informatica with PDO, which is, I guess, Teradata enabled, where transformation is in the procedures or macros rather than Informatica components?
So in terms of that, so QuerySurge definitely integrates with Informatica, and we communicate perfectly with Teradata. If you're using, say, stored procs or macros, if the tables are being generated, QuerySurge is going to test before and after. If there's a need to test a macro or a function call, you can call one of those particular items directly from your query pair. So we support a multi-statement architecture. So if you needed to call a procedure, create a view, or any of those items, you can have those steps done and call that information. The only thing that's important to note is in order to validate that transformation, you're going to need to replicate that code or create a business rule that will validate that data set. What's important to note with QuerySurge is we always recommend that testing team members understand the logic that's being put in. So if there's a transformation rule that is being done in a procedure or from a ETL tool such as Puntaho, they're going to have to find a way to massage that data in order to validate it. So you should have absolutely no problems calling a procedure, macro, using Informatica directly, and obviously communicating with Teradata. I do have an example, and I can pull that up real quick on my other instance over here, where we have a multi-statement example. And a multi-statement example is pretty straightforward. It's exactly how you would expect it to look. And let me just pull that up right here. So in this particular case, we are creating a view, which you see right here. We are inserting into that view, and we could be calling a procedure or a macro. And then we are actually selecting from that view and eventually dropping that table. So if that data is not a static table that's being generated and it's something more fluid like we see here, you can definitely do that.
Great. We're running out of time, so that's going to wrap up our Q&A session. Thanks again, everyone, for your time and participation today. We'll be sending a follow-up email to you with a link to our recording and our contact information if you have any additional questions. Thanks again, everyone, and have a great day.